All right, the learning objective here is that all students will develop the unit circle, including all angles, radians, and coordinates. So this is our unit circle. So let's just kind of talk about something. It's called the unit circle because if you start here at the origin, which is the center here, you got 1 unit. That means that this distance is 1, 0. That's the coordinate right there. 1 spot, 1 unit. Well, if I start at the origin and I go up 1 unit, then I'm going to be at 0, 1. Same thing here. If I start at the origin and I go left 1 unit, I'm going to be at -1, 0. And if I start at the origin and I go down 1 unit, I'm going to be at 0, -1. Okay, but what are these in degrees? This is 0 degrees because I'm starting here. This one up here is 90 degrees. We've established that last week. Another 90. Another 90. And then another 90. So 0 degrees is the exact same spot as 360 because a full circle is 360 degrees. And then I could just keep rotating around if I wanted to. But what are the in-between ones? Okay, well this guy right here, it's halfway between 0 and 90. So what's halfway? 45. Alright, this guy here is halfway between 90 and 180. So yeah, you could find the halfway mark, or technically you can just kind of keep adding 45 on. So if I take 90 and add 45, I'll get what? Okay, 135. Same thing here. This is the halfway mark, so I can figure out exactly halfway between 180 and 270. Or I can just take 180 and add 45 on, and I'll get 225. Same thing here, right here. That's halfway between 270 and 360. So if you can't figure that out, you can take your 270 and add 45 on, and you'll see that this is 315. Okay, now let's talk about the other angles here. This right here is not equally distance between these two, but instead you want to kind of look at this, and this, and this, and this. Okay, so what we're doing is we're going from here to here, from here to here, and from here to here, and we're split it into 3 equal sections. So if the whole thing here is 90, and I split it into 3 equal sections, they're each going to be 30 degrees. So if this is 0 degrees, and I add 30 on, I'll get 30. And I add another 30 on, I'll get 60. Add another 30 on, and I'll get 90. Another 30 added on to 90. Another 30. 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 And one more 30 will bring me back to 360. So your objective was to learn all the angles in the unit circle. So pretty much we're just talking about multiples of 30 and multiples of 45 all the way around. Alright, but part of the objective said not only to learn the unit circle and angles, but learn them in radian form. So, do you really want to go through for each of these and do that formula that converts from degrees to radians? No, that would take too long, too tedious, and unnecessary. So I'm going to teach you a little trick here on the radian form. Alright, the beginning of here is 0 pi, and if I finish out an angle, if I finish out the circle, I'll end up with 2 pi. So 0 pi is the same as 0 degrees, and 2 pi is the same as 360 degrees. But they're all at this spot right here. So what I want you to do is recognize that there's 2 patterns here. There's a pattern for your multiples of 45 degrees, and then there's a different pattern for your multiples of 30 degrees. And really, I mean, you may feel very overwhelmed with this. Really, you're just going to learn the first quadrant, and then after that, you're going to just reflect things over. Because if you look over here, they're all just reflections on the other sides. Okay. So let's start with the multiples of 45 degrees. Okay, so what I did here is I kind of color-coded it for you. I'm going to show you that if we split it into 45 degrees, every 45 degrees is another color here, right? So it goes, the first 45 is in blue, then in green, then in blue, then in green, in blue, green, blue, green. So there's sections here. Well, I just want you to look at the top section. Your pattern only looks at the top section of the circle, or the top half. If you look, there's one section here, another section, another section, and another section. So that's how many sections? That's 4 sections. So think of these in fractions with a denominator of 4. That means that this spot right here is the first kind of barrier. So this would be 1/4, and because we're in radians, we just put pi next to it. Okay, the next one here would be 2/4, which reduces to what? A half pi. The next one is the third section, so that's 3/4 pi. And then this one would be 4/4, which reduces just to 1 pi. The next section would be 5/4. The next one would be 6/4, but that reduces to 3/2 pi. And the next section is 7/4 pi, which can't be reduced. The next one would have been 8/4, but 8/4 reduces to this 2 pi we already established. So you don't need to take all your angles and transform them with a formula that we learned a couple of videos back and do all of them times pi over 180, times pi over 180, times pi over 180. Instead, just recognize the pattern. If it's the 45 degree, which is the very center part, we're going to think of it as in 4 sections on top, so the denominator is out of 4. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Okay? But now, that's not all the radians, right? Those are only the patterns of 45 degrees. So what are we going to do with the patterns of 30 degrees? I'll get to that. Okay, so if it's a pattern of the 30 degrees, what I did is I kind of separated every 30 degrees into another color. But again, I just want you to look at the top section only. The top section of the circle will allow you to figure out the pattern. How many pieces are there on that top section? 1, 2, 3, 4, 5, 6. So that means your fractions denominator will be 6. So this will be 1/6 pi. Oops, I should have started here. 0 pi. 1/6. This would have been 2/6, but remember that 2/6 reduces to 1/3. Okay, this would have been 3/6, but 3/6 reduces to 1/2, which we already established. 4/6 reduces to what? Okay, 5/6, which can't be reduced. This would be 6/6, which reduces to 1 pi, which we've already shown on a previous slide. Okay, now we're just going to continue that pattern. Next one would be 7/6. 8/6, but 8/6 reduces to 4/3. Okay, this would be 9/6, but 9/6 reduces to 3/2, which we've shown on the previous slide. This would be 10/6, but 10/6 reduces to 5/3. This would be 11/6, which can't be reduced. And then this would be 12/6, but remember that 12/6 reduces to just 2 pi, which we've shown on a previous slide. So to learn these angle measurements in radians, it's not like you have to memorize a ton of fractions. All you need to do is continue the pattern. Another thing that's very helpful is if you can just remember in the first quadrant, these 3 right here, one of them is going to be 1/6, one's going to be 1/3, and one's going to be 1/4. So which is which? Remember the middle one always has a denominator 4, so you know that that one's the 1/4. And then between these two, this is actually smaller, it's actually closer to the x-axis. Fractional form, which one is smaller here? 1/6. And this is 1/3. And then from there on, you're just going to use everything you know from the first quadrant to get all the other ones over here.